video, we're going to talk about solving quadratic equations and looking at the value of the discriminant. The first thing you should really know is that quadratic equations can have 0, 1, or 2 real solutions. And their real solutions are actually the same places that that graph crosses the x-axis. The reason for that is whenever you solve a quadratic, you always set it equal to 0. And when you set it equal to 0, what you're actually doing, so for example, if you had like something like y equals x squared minus 9. When you set that equal to 0, you're actually saying that y is equal to 0, so that would happen at the x-intercepts. So the x-intercepts in this case here, we have two x-intercepts, so this one has 2 solutions. We have one x-intercept, so this one has 1 real solution. And then we have this one here that has 0 real solutions because it never crosses the x-axis. Now, it's still going to have 2 solutions. They're just not real. They're imaginary. You should actually be able to tell, and most teachers would expect you to know, if it doesn't cross the x-axis, then what is its discriminant? Not necessarily the value, but just if it's positive, negative, or 0. So going back, you should really remember that the discriminant is simply b squared minus 4ac. And it's part of the quadratic formula. This is the part under the square root. So if it is positive when you figure it out, doesn't matter what number it is, but if it's positive, that just means you have 2 real solutions. If it's negative, you have no real solutions. So if the discriminant is actually negative, you have no real solutions or 0 real solutions. Now that's not to say you don't have solutions. Again, you just have imaginary solutions. And lastly, and this is the most confusing, if you get 0 for the discriminant, that means you're going to have 1 solution to the quadratic equation. So here's what this means. Well, this one crosses the x-axis twice, this one never crosses the x-axis, and this one crosses the x-axis once. So if we go back and we look, here, the discriminant, we're just going to use d, the discriminant is going to be negative. Here, the discriminant is going to be 0 because it crosses once. And here, the discriminant is going to be positive because it crosses twice. And then, again, this one has imaginary solutions because it never crosses the x-axis. Now, to solve quadratic equations, what we're looking at right here is if there's an x squared term and also an x term, so there's an a and a b, then you actually have to factor it. In this case, where there's no b term, or ABC if you're going in that order, if there's no x and x squared, then you could just go ahead and take the square root. So if we take a look at this one, we're factoring, and what we need are factors of 28 that subtract to positive 3. So we need numbers that multiply together that give us 28, but that when we subtract those 2 factors, we actually get positive 3. So the easiest way to do that is just to come over here and factor 28 if you can't think of them in your head. So that'd be 1 and 28. Those subtract to 27 or negative 27. You could take 2 and 14. Those subtract to 12 or negative 12. And 3 doesn't go into 28. So we have 4 times 7. And here we go. That actually subtracts to 3 if we do it correctly, if we use the right sign. So set up 2 sets of parentheses. And we'll put an x first. That's going to take care of this x squared term. And now we're going to put 4 and 7 in here. Doesn't matter what order you put them in because you're multiplying. This last term is negative. So when I multiply 2 numbers together, if I want to get a negative, then I know I have to have 1 positive and 1 negative. Now you can't just arbitrarily, put, oh, this one's positive and this one's negative. You have to look at the middle term. Because when I combine 7 and 4, I want to get positive 3. I don't want to get negative 3. So if I make the 7 positive and then I subtract off 4, that's going to give me positive 3. If I would have switched that and I made this negative 7 and this positive 4, I actually would have ended up with negative 3 for my middle term. So this is the 0 product property right here. You just set these equal to 0. So x minus 4 equals 0. X plus 7 equals 0. And we have 2 really simple equations here. Add 4 to both sides and you get that x is equal to 4. And on this one, you subtract 7, you get x is equal to negative 7. So the 2 solutions to this quadratic equation are 4 and negative 7. And if you were to graph this quadratic, it would cross the x-axis over at negative 7 and then to the right at positive 4. One more to take a look at. If you look at this one right here, again, this one does not need to be factored. So we're going to go ahead and subtract 49 from both sides so that we get the x squared by itself. we get x squared equals negative 49. Now, if you can even think about that, what number could you possibly square to get a negative 49? There's no real number that does that, because anytime you square a number, you're going to get a positive. Even when you try to take the square root, which is how you would actually solve this, you get x is equal to the square root, or plus or minus, the square root of negative 49, and there's no such thing in real numbers. So this has no real solutions. Now the deal is it actually does have imaginary solutions, but we're not going to talk about that yet. But this actually has no real solution, so it actually never crosses the x-axis.